The functions f and g are defined by f of x is equal to 9 over 2x plus 1 and g of x is equal to x minus 3. Find in its simplest form an expression for f inverse of x. And that is how it is written, and that is how it is read. F inverse of x. On this occasion, we are not focusing on the function g. The function g will not be involved in this exercise. Now there we have the power of negative 1. In function notation, when the function is raised to the power of negative 1, we are referring to its inverse, which is different from the inverse of an algebraic expression. It is the reverse of the function, or the complete reverse of the function on this occasion, which means that we will do the reverse of the process of which the function is responsible. Now, how do we achieve that in an algebraic manner? That is what we need to take a look at. We need to write an expression for the inverse of f, or for f inverse. What do we do? The inverse of a function is its complete reverse. The inverse of a function is its complete reverse, or it is the complete reversal of its operation. This may be done algebraically by first replacing f of x with x and x with f of x. And here we have f of x in inverted commas, which means that it's not actually, but we will see why in a short while, it is in inverted commas. In inversing the function, the first step that we will take is to replace f of x with x and x, so to speak, with f of x. So we are going to make that switch. Where we had f of x, we now have x. And where we had x, we now have f of x. However, in the end, what we are actually finding is the inverse of the function f, not f of x itself. We are actually finding the inverse of the function, or f inverse. Therefore, it is more appropriate to replace x not with f of x, but with the inverse of f. So the inverse is more appropriately placed there, because in the end, what we will achieve by transposition will actually be the inverse of the function and not the function itself. We will next use the process of transposition to make f inverse of x the subject of the formula. And of course, by so doing, the expression will be the inverse of f of x. The expression on the right hand side will be the algebraic representation of f inverse of x. So when we have completed the transposition process, what we will have on the right hand side is the inverse of the function. We move to another slide and we will achieve that right there. By transposition, we will find an expression for f inverse of x. What do we do first? Begin transposing by eliminating the denominator by multiplying by 2 f inverse x plus 1. So we will eliminate this denominator that we have here by multiplying by the exact denominator. We are cancelling it from the right hand side. By multiplying by the entire denominator on the right hand side, we will eliminate the entire denominator. But we cannot do that on one side alone. We have to keep the equation balanced by multiplying by the exact same thing on the other side of the equation. On the right hand side, the denominator is eliminated. And on the left-hand side, we will have to multiply the entire left-hand side, which is just simply x, by whatever we had as the denominator on the right-hand side, which turns out to be 2 f inverse of x plus 1. So we have the elimination of the denominator on the right-hand side. We will now multiply the left-hand side, and we'll go straight ahead. With f inverse of x inside of the brackets here, we will expand the brackets in order to get a hold of the term that contains it. We need f inverse of x. Therefore, we need to get a hold of the term that contains f inverse of x. It is inside of this large square brackets. We need to expand the brackets so we can have a better grip on our proposed subject, which is f inverse of x. By expansion, we can see here the animation demonstrating what is to be done. X will multiply by 2 f inverse x. So we will have 2x f inverse x as the result. And the other part of it is quite simple, where we will multiply x by just 1, and that will give us x. So on the left-hand side, we have 2 f inverse x plus 1, and on the right-hand side, everything will be eliminated except the 9 that we have there. Now we have 1 here, but 9 divided by 1 will be 9 nonetheless, so it's just 9 on that right-hand side. Our next step, of course, is another step of transposition, which will eliminate all the terms that do not contain f inverse x from that left-hand side. Now f inverse of x is on the left-hand side, and we need to eliminate all of those terms that do not contain f inverse x from the left-hand side, if there is any such term. And there is a particular term right here, x plus x. We will eliminate that term immediately. Eliminate x from the left-hand side by subtracting x, and balance the equation by subtracting x from the right-hand side also. So what we have here is plus x. We need to do the opposite of plus x in order to eliminate this plus x from this left-hand side. Minus x, so we will minus x from the other side also. In our next step, the x's on the left-hand side would have been eliminated, and all that we have left is 2x f inverse x, which means that we will have to eliminate this 2x that is multiplying f inverse x. And how do we do that? Finish up by eliminating 2x from the left-hand side by dividing by 2x, and balance the equation by dividing by 2x on the right-hand side also. This 2x is related to f inverse of x by multiplication. We will therefore do the opposite of multiplying by 2x, which is divide by 2x. So we will divide by 2x on that left-hand side and balance the equation by dividing by 2x on the right-hand side also. There we have it. And there we have the elimination of 2x from the left-hand side, which means that all that remains there is f inverse of x. And on the right-hand side, we just have 9 minus x over 2x. Consequently, we have the total elimination of the 2x from the left-hand side, meaning that we have f inverse of x is equal to 9 minus x over 2x. And that is how we would have completed the transposition process, which results in the expression for f inverse of x.
For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.